Hello, everybody. Very welcome to Kerry International Dark Sky Reserve, where tonight we're bringing you the sun, the moon, and the stars. We have a very interesting couple of talks. John Flannery from the Irish Astronomical Society will be, as usual, giving us the thoughts on what's in the night sky for the month of May. We're joined by Jane Sheehan, who's going to talk about the moon and its influence on the tides. John, I know, will mention sunspots, so that's where we get the sun, the moon, and the stars. As ever, if there are any queries, questions arising, please let us have them, and we'll do our best to answer them. From our point of view, there's kind of one thing to mention coming up this weekend, not directly star related, but certainly lots of stars were here for a while, a couple of years back, for the filming of the Star Wars movies. And there's a festival, the Fourth Be With You festival this weekend, centered down here in Portmagee and Valencia. Just to be aware of that, there's lots of information. Just search the Fourth Be With You. Last week was Dark Sky Week, 22nd to the 29th of April. We actually had a dark sky event here on the beach of Ballinskelligs. Got a lovely evening for us, and it was very pleasant. We've had lots of grey skies and lots of claggy cloud over the last week or two, but hopefully the weather will get a little bit better, and the stars and other night items that John will talk to you about will be visible. So without any further ado, over to John Flannery.
Thanks very much, Steve. Thanks, Orla, Claudia, and Jane. And as Steve said, I'll just talk a little about well, the sun to begin with, because we are coming into the longer day. Well, with the longer days and shorter nights, it's really extraordinary how late it stays bright in the evening sky. Even a good bit after 10 o'clock, you will notice the sky is still quite light, especially towards the western skyline. But the solar activity is picking up. These were a number of big sunspot groups that were crossing the solar disk, each with a diameter larger than the Earth. And I used just a homemade solar filter where I cut a circular piece of solar filter material, put it in a cap of a Sudocrem tub, and cut out the lid. So I was just left with the rim, and glued on the solar material, and it fitted exactly and snugly, that's the important thing, over the front of the 300mm lens for my Canon camera. Now this image is magnified to put on the slide. Like on screen, the image is much smaller, but you could pick out the sunspots quite easily when I took the photograph. And those sunspots have now gone off the solar disk, but there's some other ones have rotated onto it. The sun, because it's not like all spherical bodies, it's rotating like the Earth rotates, but because it's not solid, the sun rotates at different rates. In fact, it weirdly rotates faster at its equator than at the poles. It rotates in about 25 days at the equator and about 29 days at the pole. That dissimilar rotation is how the sun's magnetic fields get tangled up, rather like if you got a fistful of rubber bands and twisted them, eventually the stress on the bands will cause them to snap. And that's a very simplistic explanation of how solar flares occur. If you go onto spaceweather.com, the page today features a sunspot group that's currently on the solar disk and has produced numerous flares. That's the spot group there. And one of those flares they think might give a glancing blow of the Earth's magnetic field in a couple of days' time, and potentially maybe trigger displays in northern and southern lights, albeit at very high latitudes. But if we don't see the aurora this time, we've a good chance over the next few years, because the current sunspot cycle will not peak until around the year 2025. So we're going to see lots more solar activity, lots more explosions on the solar surface, material and charged particles flowing Earth's direction collide with the Earth's magnetic field. Those electrically charged particles spiral in towards the north and south magnetic poles and slam into the gases of our upper atmosphere, causing them to glow, basically exciting the electrons in the atoms of those gases. They move to a higher charge plane. Then when they lose energy, they drop back down, but that loss of energy is what causes it to glow. Rather like a neon sign, it's a tube filled with gas, and an electric charge passes through the gases in the neon tube, causing them to glow. But this spot group, you can the only really safe way to observe sunspots is to project the image, to either use a pair of binoculars, align it with the sun, cap one of the objectives on the front, and then project the image onto a piece of card just behind, and that will allow you to see the spot groups. You can rest the binoculars on maybe a beanbag or something up on the height, or on a chair or something like that, and then hold the piece of card, and you can then focus and get a nice sharp image. Or a telescope, a small telescope is well worth doing, but always keep in mind the safety aspect, because if you look directly at the sun through an unfiltered instrument, you risk instant blindness. So it can be a very dangerous practice, but if you do it safely, you can see the sunspots on the solar disk. The sun's family of planets have been putting on various displays over the last few weeks, and Mercury is still on view in the western sky after sunset. It passed near the Pleiades star cluster a few days ago, has now moved a little bit beyond it. But as I mentioned, the bright and persistent twilight that we're now getting at this time of year means that it'd be very difficult to see the Pleiades directly until they're almost near setting, when the sky is that bit darker. To see the Pleiades, as this graphic shows, 45 minutes after sunset, you will need to use binoculars. In fact, Mercury is getting a bit faint as well, and can be a bit elusive in the twilight. But if you can see, like what should pop out in the twilight though are the orange giant stars, Betelgeuse and Aldebaran. So you can kind of use, if you can see Aldebaran, just go a little bit to its right, scan with binoculars, and you should sweep up Mercury in the Pleiades. It's not a good time of year to see Mercury at the moment, because, like, even though it's well placed, it's that twilight sky is going to make it a bit of a challenge to spot. But if you see it, consider yourself, they say only 1% of the Earth's population have ever seen Mercury. Still a substantial number of people, but but you can join that exclusive club if you manage to spy the messenger of the gods, just popping up to say hello before it dives back down into the solar glare again. Mercury is best seen in the morning sky in the autumn because it's then also rises or moves quite a bit away from the solar glare, and we can pick it out in the morning sky kind of late September and during October. But we'll say more about that later in the year. The morning sky is where the rest of the so-called classical planets are gathering. We call them the classical planets because these are the planets known before, well, known to the ancients and known to everyone else until the planet Uranus was found in 1781. They're the naked eye planets, the ones easily visible to the unaided eye, the ones that were considered the only members of the solar system along with the Earth, Moon, and Sun. But all four of the rest of the classical planets are gathered in a sweep from the east to the southeast before sunrise. And this is the view tomorrow morning, but they'll remain like in that general alignment for a while. And in fact, when we get later towards the end of June, Mercury will join them. And intriguingly, we'll also have the 5 classical planets in the order of their distance from the Sun at that time. Mercury closest to the horizon, then Venus, then Mars, then Jupiter, and then Saturn. So that'll be quite an interesting opportunity to pick out all of them together in the morning sky towards the end of June. But for the moment, again, a bit elusive to see. Mars, a couple of people said they managed to spot Saturn and Venus. They couldn't see Jupiter because it was too close to the horizon about a week ago. Mars is still faint and was kind of swamped by twilight. But if you get an opportunity and you're up 5 a.m., this image is for, so it's quite early in the morning sky. But I got up one morning last week. Unfortunately, it was a bit cloud. There was a small cloud bank on the eastern skyline, so I couldn't see Venus and Jupiter. But the dawning chorus was absolutely mesmerizing. It was just gorgeous to listen to it for a while before I went back to bed. But certainly, if you do get an opportunity to be, or if you are up that early, you have a nice string of pearls of planets on the ecliptic string. The ecliptic is the plane of the solar system. But the real highlight, again, an early morning rise, is a lunar eclipse that will occur on the morning of May 16th. Unfortunately, the moon will set while it's still in totality. The challenge again will be a brightening sky, where the moon will appear dark against the dawn, but it should be possible to see it until just before it sets, given the clear western skyline. But this graphic from Sky and Telescope magazine uses what's called UT. The times are in UT, which is universal time, or is what we would call winter time. Astronomers use winter time all year round because it's just easier to stick to the one standard rather than give times in summertime, because then it gets confusing as to when an event actually happened. So it's just a way of standardizing the times, but totality begins at 4:30 in the morning. Mid-eclipse is 5:15, and the moon sets just a little before mid-eclipse. And the next kind of graphic is from timeanddate.com. So maximum eclipse, the moonset is just around 5:30. So yeah, sunrise would be around then, because as the full moon sets, the sun is coming up because they're directly opposite each other in the sky. Now the times here are in summertime. So it basically says the penumbral eclipse begins. That's when the outer edge of the Earth's shadow that's cast into space is just brushing the disk of the moon. But it's very difficult, well, it's impossible to see that particular event because it's so vague and vaporous a shadow. It's basically not going to be visible. It's just the shadow is just barely there, so you won't notice any dimming of the moon at all. It's only until the moon is about 70% immersed in the penumbral part of the Earth's shadow that you begin to start seeing some sort of dimming on the leading edge of the moon, and that should occur around 3 a.m. in the morning. Then the partial eclipse, where, as it says there, you will begin to notice a slight reddening at the leading part of the Earth's shadow. I always like looking at the leading part of the shadow as it's crossing the disk with binoculars, because you can notice some interesting effects. One time in the 20s, it was the 2015 lunar eclipse, which actually was a supermoon. In fact, I forgot to say here, this is also a supermoon as well. Full moon on May 16th, it's a supermoon, and it's the closest full moon of 2022. But when you look at the leading edge of the shadow, you might notice a slight bluish fringe to it, and that's basically Earth's ozone layer absorbing some sunlight and just showing that bluish tinge to it. So it can be seen, and it's quite an interesting effect. Sometimes, depending on the amount of aerosols in Earth's atmosphere. Now, when I say aerosols, it would be volcanic dust, like the volcano that erupted in Tonga, through, like, its material was ejected to a height greater than that of Krakatoa. So it actually reached the stratosphere. And if a lot of that material is suspended aloft still, it can make the eclipse appear darker than expected. That actually happened with the December 1992 eclipse, where the Mount Pinatubo had erupted in the Philippines in July 1991 and flung a lot of material high into the atmosphere. And that spread it in the upper atmosphere winds around the world. And the eclipse in December 1992 was the darkest eclipse I've ever seen. Normally you expect the moon to turn maybe an orange-red color, but in this particular eclipse, it was gray. The moon was almost invisible mid-eclipse. Like, the description I used at the time was, it looked like a tarnished ball bearing in the sky. So it was really an extraordinary sight, and I've never seen anything like it since with lunar eclipses. So if the atmosphere is choked with volcanic dust, then it can introduce a number of interesting effects. But total eclipse then begins at 4:30. The moon at this stage will be only about 6 degrees above the southwestern skyline, or like your fist at arm's length is roughly 8 to 10 degrees is an angle of 8 to 10 degrees. So the moon will only be kind of a fist width above the southwestern horizon when totality begins. So if you've anything obscuring your skyline in that direction, then find somewhere where you have a clear horizon. And then maximum eclipse, where the moon is literally in the center of the Earth's shadow. The moon is almost near the horizon at that stage. It's only about 3 moon diameters above the horizon. And then moonset occurs maybe 15 minutes later. So you won't see the end of the eclipse, but you'll get some very interesting effects as well. The whole effect of what will the eclipse look like when the sky is getting quite bright, and that's what makes eclipses so interesting. Every single one is varied, especially lunar eclipses. Solar eclipses are equally as varied, but even more spectacular. But the beauty of lunar eclipse is it's a leisurely event. It takes place over a few hours. A solar eclipse, on the other hand, totality only lasts a maximum of 6.5 minutes. Most are only 2 to 3 minutes. So you literally are rushed to see what all the effects during a solar eclipse. In fact, a friend of mine said he didn't really consider solar eclipses the best event he ever saw. He considered a really good display of the Northern Lights, greatest astronomical sight he ever saw, because he could appreciate it at leisure. A solar eclipse is rushed. A lunar eclipse, just sit back, enjoy, and fingers crossed for clear skies. Just to cover one last thing, an interesting group of stars is visible at this time of year in the southern sky after dark. Under the tail of Great Bear is the constellation of Coma Berenices, or just to the left of Leo the Lion, which is quite distinctive by the backward question mark of stars anchored by the bright star Regulus. That backward question mark is often nicknamed the sickle, but the Coma star cluster is sometimes, well, in ancient records, is considered the tuft of the tail of the lion. But in more modern times, when like roughly around the Middle Ages, a different legend crept in. It's actually centers around real characters. Queen Berenices of Egypt was a real person, along with her husband Ptolemy III. And Queen Berenices allegedly shaved off she was famous for having beautiful hair. She shaved it all off, offered it to Aphrodite as a sacrifice for the safe return of her husband from battle. Overnight, the shorn locks disappeared from the temple. And of course, the king and queen were extremely angry at this, but were placated by the chief priest, who said that during the night, Aphrodite took the tresses and placed them in the sky to acknowledge Queen Berenice's sacrifice. And those tresses are the straggle of stars. We see here the Coma star cluster. It's the second closest star cluster to the solar system. And binoculars are really the only way you'll appreciate this group, or with the naked eye, because they're so spread out. But they're a lovely little group to identify. What's also interesting is this NGP is the North Galactic Pole. It's basically the North Pole of the Milky Way galaxy. So from our perspective, like the Milky Way is a flat plane, well, is a disk in a flat plane, and the Coma star cluster is directly overhead from our perspective. So we're looking up and out of the plane of our galaxy into the deeper universe beyond. And looking in that direction, because we're looking into the deeper universe beyond, we're also seeing the rich galaxy clusters. The Virgo galaxy group has several thousand member galaxies, all bound by gravitational forces. In fact, our own Milky Way is part of a cluster of about 50 galaxies called the local group. And that local group is part of the Virgo supercluster, which is equally part of another gigantic structure of a number of superclusters of galaxies, which is equally part of an even bigger structure called Lynott. And then, just to finish up, mentioning Lynott is it's one of the topics that's going to be touched on by Jim Al-Khalili, the presenter and scientist. He has a new BBC series. I think it's only 2 parts starting in the summer. And it's basically exploring the universe from the very small to the very big. So keep an eye out on BBC4 for that particular series starting, because Jim Al-Khalili's previous series have been really extraordinary in revealing topics about science and the world around us. So just to wrap up, as Orla said, the notes are going to be online. The calendar is there, highlighting a number of the events I've mentioned and many other things occurring. And the usual notes there will bring you to a lot more information about what's happening in the sky. So hopefully, fingers crossed for the morning of May 16th. So do get in touch and let us know how you get on. In fact, one thing I also discovered is from Finian's Bay, the moon will set behind Skellig Vigil during totality. So if there's any keen photographers out there, there's something to check on PhotoPills or one of the apps that allow you to simulate moonset in relation to the landscape. And it was through PhotoPills that I saw that moonset is behind the Skellig, and that would be a photo for the ages. So do try it, and fingers crossed we do have clear skies to capture the another wonder of the sky. Thanks very much.
Thank you very much, John. Actually, one of the things we might do is pull some PhotoPills information up and put it on both the Kerry Dark Sky Tourism and live Facebook and web pages, so that there are a few spots. The GeoCom on the top of the mountain in Valencia would be another interesting point. Braehead would be as well, but getting up there at that hour of the night is kind of a bit of a challenge. So GeoCom, you can drive up to the top. So from that point of view, it's got attractions. So we'll check it out, and we'll get some information up there.
Okay.
So we've handled the sun and a bit of the moon. We're going now to Jane Sheehan. Jane is going to talk to us about something that obviously we're kind of very conscious of, the movement of the sea in Kerry. There's very little of Kerry where you aren't seeing a bit of the sea somewhere along the way. So without further ado, Jane is going to talk to us about the moon and its impact on tides and on ourselves indeed. Jane, thank you.
Thanks, Steve. And thank you, John, for a lovely presentation again. I'll just start sharing my screen now. Bear with me a second. Is that okay for everyone?
Yep.
Yeah, that's perfect.
Brilliant. Yeah, so I'm Jane. I'm a knowledge gatherer as part of the LIFE project, and I'm a marine biologist. So understanding how the moon affects our oceans is something that would be really, really important for any marine biologist. But it's always been something that I found really, really hard to get my head around. I think when you're talking about something like gravity, it's something you can't see. It's difficult to get your head around. So I thought it'd be a really nice opportunity to just put a really, really brief presentation together on how exactly the moon affects our oceans. It being the week it was, I went for a Star Wars fun as well. When you see the tide roll in and out, what you're really seeing is kind of a cycle of small changes, the distribution of the planet's oceans. As I was saying there earlier, gravity, it's an invisible force, and it's what pulls objects towards each other. And anything which has mass will have gravity, and Earth is famously quite big. So the moon actually plays a huge role in our sea by influencing the ocean's tides, and the gravity of Earth along with the gravitational pull of the moon is what creates tidal force. So I actually got these lovely graphics from NASA's website. They have a lot of nice information on tides in the moon as well. So if anyone wants to look up anything after, it's just going there. But I found these animations really, really helpful. Because I remember when I was in college and trying to get my head around tides, you had all these like really complicated images with axes and all these different shapes. And I found these are really, really nice and really, really easy to understand. So as you can see here, you can see the gravity pulling on Earth and creating these tidal bulges. And I think another thing that, like, when you see those tidal bulges, you see it when you see the moon pulling on Earth. One of the first things I used to always think was, why is it happening at both sides? Like, why are you seeing that kind of shape? And this is actually because as the Earth rotates, it pulls, it's the area that's closest to the moon experiences its gravitational pull, but also the side furthest to it. And this is because the moon's gravity affects the entirety of the Earth. It pulls at every point on our planet, not just the side closest to us. And it pulls at its mass, and it shifts that shape into that of what I would say is a rugby ball. It's longer at the equator and it's shorter at the poles. You can kind of see that happening in that animation there. And another thing that I think I used to always ask anyway was, well, you know, if we're only rotating past the moon once a day, how come we're experiencing two tides? And here I think that animation just shows that perfectly. This is because, you know, the Earth, it's passing through this kind of bulging layer of water. And it's therefore allowing us to experience not only the low tide, but the high tide as well. And the tide cycle, it's roughly around 12 hours. You get certain locations where it's different. I know in Lochine, to do with the narrowness of the channel that goes in there, they experience a completely different tide cycle. I think it's like 8 hours on one side. But your usual tide cycle will be around 12 hours. And not only would the moon have a great effect on our tide cycle, but the sun also has a role in the monthly tide cycle as well. The sun also has gravity, being quite big as well. So during the full moons and the new moons for the Earth and the moon and the sun line up, those gravitational powers combine and they create extreme tides. So as you can see here on the animation, you can see that the moon and the Earth and the sun are lining up there when they're straight across the way from each other. You can see there again, you can see how big the resulting tide is. If you look over at the legend in the corner there, it'll show you the difference between the solar tide, the lunar tide, and the resulting tide. And so this bulge will create not only exceptionally high tides, which are known as the spring tides, but the displacement of this water will also create really, really low tides as well. So during the full and the new moons, you will be expected to see that those really, really high tides and then the really, really low tides. And then if you're familiar with the term neap tides, that's when the first and the last quarter moon, it's when the moon's orbit around the Earth brings it almost perpendicular to the sun. So you can see in a few seconds there, it's at a right angle to it. And because of this right angle shape, their gravitational pulls begin to combat each other and they cancel each other out. And this creates the smaller and the more moderate tides. And I suppose just before I go on to how the moon can influence other aspects of the sea, I found something really, really helpful to me as a marine biologist is just getting tide tables for your location. I used to use a lot of tide apps, but I think hands down the tide tables are the easiest to refer to. So not only does the moon influence our tides cycle on a daily basis and on a monthly basis, but it also can influence different forms of marine life too. So species of zooplankton, sort of small floating kind of animals in our water, they respond to the rise and the set of the moon. So they actually do this great migration every single night where they come up from the deep sea to feed on the algae at the surface of the ocean. But really interestingly, in the Arctic, the zooplankton there actually have internal clocks which are set to the moon. And this is because whenever there is, a full moon with really good visibility, that means that the predators which will prey on the zooplankton are getting really, really great illumination as well. So it's a great opportunity for them to go out hunting zooplankton. And because of this, the zooplankton have this internal clock which helps them adapt. And it gets what they do then is they hide underneath the water, kind of deeper in the water, while the moon is on horizon for those kind of several days in the Arctic. Another kind of influence the moon would have would be on oysters. So interestingly enough, the oysters stay more open during a new moon and more closed during a full moon. They can tell the difference between the first and the last quarter of the moon. And they only stay slightly open during this time. And this may be because the lunar cycle influences different food availability. As the moon is influencing the tides and the currents, you can get different forms of nutrients and different temperatures of water coming in as well. And I think one of the most fantastic kind of influences the moon has on the ocean would be the coordination of mass spawning events. So if anyone ever watches anything about coral, you'll hear about these great spawning events where they will release their eggs and sperm into the water based on the moon phases. Especially, I think we've all heard of the Great Barrier Reef mass annual spawning. It's not just corals, you'll have fish species and invertebrates, certain species of marine worm that also coordinates mass spawning events. And they use the term broadcast spawning because it's so precisely timed, which is really, really fascinating. And just some other moon influences on marine species. There's a speckled sea louse, which has a 12.4 lunar clock, and also a monthly lunar cycle. So it's daily internal clock coincides with the tides, and then it's monthly lunar cycle means it's active during full moons and no moons and new moons because of the stronger currents, and it's not active during a quarter moon phase and neap tides. You'll see squid which match their bioluminescent glow to the amount of moonlight in the area. This makes them nice and camouflaged for other predators, and they almost just look like the reflection of the moon in the water. Similar to the speckled sea louse, the sandhoppers, instead of having kind of they have a lunar clock within their antennae, but they also have a solar clock within their brain and antennae, and this helps them navigate up and down the shore. So in these cases, when there's low tide, they'll be feeding in the area And then obviously when the high tide comes in, they either move up the shore. It's also said that moonlight helps baby fish grow, so it illuminates their prey, such as like those zooplankton, as I was saying earlier. The moon shines on them, makes them really, really visible. And this moonlight was, even though it's bad for the zooplankton, it's actually very good for the baby fish, because it means that they can prey on their delicious zooplankton and grow. So yeah, they're just some of the small ways that I suppose the celestial bodies have effects on our oceans. And yeah, thank you very much. And if anybody has any questions, please just let me know at the end of the talk.
Jane, thank you very, very much. Fascinating that we all need mechanical devices or electronic devices to tell us the time. I have even greater respect for sandhoppers now that they don't need anything to tell them either the moon or the sun. Actually, something that I was reminded of as you spoke, there's a very good friend of mine who does a lot of diving. And he was telling me some time ago that I just found it quite fascinating that there are various cliffs around Kerry where guillemots nest. And when they're nesting and producing eggs, obviously with so many of them there, lots of eggs end up popping off the cliff and going down into the sea. And to his total amazement, millions and millions of starfish appear under these cliffs at the time of the eggs dropping.
No way. And
they're only there for the couple of weeks that eggs are dropping and then are gone again. So it's just you triggered something there, because when you were talking about cycles, I must check out the detail with him and maybe get some photographs for you, because it really is quite fascinating. Has anybody any other chat questions or insights?
Question there in the chat about Rhonda, who's traveling to Ireland from Canada, and she's going to be staying near Sneem, and she was just asking, is there a certain night you'd suggest for best viewing? I know you put something in the chat, Steve, already, but just in case other people can't see the chat. Yeah,
there's two considerations, obviously. One is the weather, which unfortunately, because of the Atlantic, is quite unpredictable, although I had a look at the best of the long-term apps and mentioned that the 11th looks okay. But the moon is actually near full moon. So it's going to be a great time to look at the moon, but it is going to wash out stars next week. Mind you, if you're around on the 16th, I'm kind of half thinking I might ask John to come down and we might do something about the moons early in the morning. It's a fascinating thought. We'll explore it and maybe come back with a bit more detail.
Mm-hmm. Well, running around with cameras at 5 o'clock in the morning, it's you guys chasing for a photograph.
Well, at least what we're chasing is moving that bit slower than normal. So that from that point of view, it's pretty easy.
There's just another question for Jane. Where is it? Oh, yes. Why doesn't the moon have much effect on rivers? I know rivers flow to the sea, but if the moon has such an effect, why doesn't it affect rivers?
I think it's just because we don't see it as much as we would see it on the beach. Because we're kind of, when we're out walking on the beach, we're kind of looking to see, whether it's the low tide or the high tide. And it's obviously, the beach is exposed when it's low tide. You will see tidal differences in rivers. At least that's what I'm aware of anyway. You will see that fluctuation. Just, I don't think you would notice it as much, perhaps.
And some rivers then would be tidal up to a certain point as well, like the Amazon and And then you get the so-called tidal bores, like in the Severn near Bristol, and and even the Liffey, I think it's tidal up to Island Bridge. So yeah, it's there pushing against it. But as you said, Jane, it's just the scale of. But the interesting thing is the Earth has a gravitational influence on the Moon, and even though the Moon has no seas or rivers, it does stress the lunar crust and raise the lunar crust by a certain amount.
Wow.
But famously as well, they also have to take into account the effects of the full moon in CERN in Geneva, because the particle accelerator is so sensitive that when the moon is overhead, it conflects the ring that the particle beam is shot around. So they have to account for the stresses of the moon and local gravitational effects when they're getting the particles to collide with each other. Yeah,
That sounds like a sci-fi film disaster waiting to happen.
Yeah.
It's a full moon and it all goes horribly wrong because they didn't calculate the
That's amazing.
yes, space lasers.
That's fascinating.
Like mini black holes being created.
Yeah. So there's another question here. Now, some of our attendees have helped answer, but I'll ask it anyway. What is the best weather forecasting app? I use Met-Éireann and XC Weather. That's from John Glynn.
I've just actually put that up on the thing there. There's an app called Xstaria, Xasteria, and they pull information from various sources, and you can actually decide on your favorite source. It's useful because it takes your location and then customizes the data for you. And if one source is down, you can select another one. So it's actually pretty good. There's a simple graphic app called Sky Live, which gives you a lovely photograph and tells you how crap the weather's going to be tonight, or whether it's good or not good tonight. It's always kind of disappointing, because it seems to me that on the nights that the weather is particularly bad, there's always a particularly gorgeous photograph of some deep sky object. But it's I must say the Xasteria is very useful, especially here, because they seem to be picking up a lot of information from off the Atlantic systems, and that obviously impacts us fairly dramatically here.
I might just add another one there, Steve. The Clear Outside is another good app. Just see, do I have it here on the phone?
The interesting thing, actually, John, is that Clear Outside is actually one of the options within the Xtaria.
Oh, is it? Okay.
Yeah,
right.
it meta blue, no water vapor, windy, atmospheric, jet stream, and Clear Outside. Okay. And they've also 7-timer, the old clunky one they've now kind of put a bit of graphics into it, you know.
Glossed it up.
Yeah.
Yeah, like Clear Outside is pretty good because it's specifically designed for astronomy. But as David said there, windy.com I use quite a bit, and yr.no, because windy.com, it can overlay the predicted cloud according to different weather models. And it kind of helped us one year for the Perseids meteor shower. It showed the whole Dublin area sucked in. We spotted a clear bit out near Turlock Hill, headed for there, and we had lovely clear skies and saw the Perseids.
Fortunately, quite often they're all consistent when there's a big front coming in off the Atlantic,
Yeah.
which is that we're going to get absolutely fantastic grey skies rather than perfect dark skies.
Yeah, I noticed the May issue of Sky at Night magazine has something about apps for iPhones, astronomy apps for iPhones. So if you there's the cover of it there.
Excellent.
So and if you have a library card, you can go on their Libby app, and Sky at Night magazine is on Libby as one of the electronic magazines you can download.
Yeah, we've saved your money as well as everything else.
That's great.
Somebody, I think, had a query about whether we're doing any. We've no planned public events. We do some private guiding from time to time, but if the weather looks particularly good, sometime in May, we'll pick a day, broadcast a few days in advance that we're doing it, and have one of our freebie events on the beach.
Sure, I could potter down that way, Steve, towards the end of May. Like,
excellent.
Because with me now mostly in Nina these days, like I'm closer to you than where I am tonight in Dublin. So.
Always welcome. Folks, one final piece of information. We've been doing these now for 12 months. Indebted to all the great speakers. John in particular has been a stalwart through all of the presentations. Currently, our plan is that the one in June will be our last one for a wee while, and we'll review then. But all the videos and recordings for the year that we've been operational are there. And with regard to the night sky, obviously the planets' movements are not the same each month. They change year on year, but the stars and the constellations that are visible are pretty much consistent so far anyway. We reckon they probably will be for another wee while too. But our next speakers are already set up for June, first Thursday in June, and then we'll be taking a break. As ever, Orla Breslin from the Live Project, who puts all this together and who does all the editing to make us sound intelligible when the videos go out. We're indebted to Clodagh Cahill as well. Thanks again to Jane and to John. And signing off, and wish you clear skies until we meet again. Take care, everybody.
Yep. See you, folks. Thanks.
Thanks. Bye.
Bye.
And just quickly, I put in Kerry Dark Sky Tourism on Facebook and Twitter. That's Steve. So if he is ever doing events, he'll put them there. So keep an eye out for that. Thanks very much.
Thank you, folks.
Thanks, Jen. Talk to you soon, Steve.
Cheers. Good night. God bless.
Bye. See you, everyone. Bye.